telecommunications industry is facing major new challenges with open architectures, cloud and edge computing, virtualization and 5G networks. And one of the biggest challenges for operators is to offer the best experience to their customers, depending on the service demanded and the customer profile. The key to turning this challenge into an opportunity is to offer the best quality of experience to the customers, and this is one of the main objectives for Telefónica and Elisa, moving forward with the development of autonomous networks which can largely manage and operate themselves without needing constant human intervention and with the exposure of their data to third parties. This ability to offer different classes of service and monitor and predict the quality of those services is likely to become of crucial importance with the new types of high-value service that 5G makes possible. The project's objective is to implement new automation use cases to improve customer experience in both Telefónica Spain and Elisa Finland 5G networks to evolve to a zero-touch customer-centric network. We need to anticipate the customer's pain points and proactively implement autonomous solutions before any degradation in services occurs to provide a seamless customer experience. Moreover, the ability to predict the customer experience will be of crucial importance with the new types of high-value services that 5G make possible. The project involves two of Europe's leading operators as champions, Telefónica and Elisa, along with partners Nokia, Optare Solutions, Elisa Polystar and NTT Data, the project leader. The key to this project is the ability to calculate and predict a customer experience KPI, as well as automate anomaly detection, root cause analysis, orchestration, and actuation and specific synchronization issues, which combines network and customer data, together with artificial intelligence and machine learning technologies to improve customer experience in a zero-touch 5G network, developing a network digital twin that manages those data in a 3D environment with historical slider and exposure to third-party services. 4 use cases have been developed in this third phase of the project that make use of the customer experience KPI to close the loop and achieve zero-touch network processes capable of anticipating degradations in the client's quality of service without human intervention. The first use case covers the prediction of CEI, or Customer Experience Index. This work was led by Nokia together with Telefónica. In phase 2 of this same catalyst, Nokia provided a methodology to compute a trusted CEI. In this new phase, CEI values will be predicted before they happen. Now, we do not want to detect a degradation in the quality of experience as soon as it occurs. Now we want to know that it is going to happen before it happens to prevent it from ever happening. And beyond operations, the ability to predict an accurate CEI opens up multiple options in an ecosystem of application developers to monetize 5G, such as enabling the circulation of autonomous cars, drones or AGVs in industrial environments on safe routes where optimal connectivity characteristics for their remote control are always guaranteed. The accuracy of our AI-based prediction model, implemented on Nokia Network Data Analytics function, was measured using data from Telefónica Spain, where we achieved an accuracy over 90%, crucial to guarantee the correctness of the actions triggered based on them. In this dashboard snapshot, where the bars represent the actual CEI values and the line represents the predictions, the degree of accuracy of the predictions can be clearly seen on live Telefónica Spain data. The second use case involves automating problem management and intent services management using persona models. This work was done by Optare Solutions and Telefónica. Personas are simply different groups of users with similar behaviors, needs, and expectations. The persona model enriches the CEI by considering the complexity of the 5G network and various customer experiences depending on the specific network service being used. This ensures that the network responds dynamically to the changing needs of different user groups. The persona model information and predictive CEI are used to improve the autonomous problem management loop for different types of 5G user, which could include people, drones, or robots. In the third use case, NTT Data develops an innovative network digital twin using data from Telefonica network and the insights generated in the project to monitor and optimize networks, as well as expose data from Telefonica's network. The network digital twin incorporates the predictive CEI and the actual CEI generated in use case 1 and the persona model data from use case 2, along with other relevant network information to offer a complete simulation of the network deployment, base station detailed data, coverage per technology, CEI per service such as gaming, streaming, instant messaging, and the prediction of the CEI in the near future. That information is superimposed on a 3D interactive map of the geographic area covered by the network with different layers of automation and a historical slider to the past and to the future. Using the digital twin to expose CEI, predictive CEI and persona model makes it easier to anticipate, predict, and enhance customer experience for different types of services and locations. Exposure of network data such as predictive CEI shown in the NTT Data digital twin is going to be critical to plan the best routes for connected and autonomous vehicles, as well as for drones and other mobility services of the future. The fourth use case, which is the joint responsibility of ELISA and ELISA Polystar, covers automated recovery from base station synchronization issues taking into consideration CEI impact. Synchronization is crucial for the proper functioning of the network and becomes even more critical with new technologies like 5G, where ultra-low latency communication and support for massive numbers of connected devices require precise timing and coordination. So this use case focuses on minimizing the impact of base station synchronization issues and the necessary remedial actions by monitoring customer experience. As we have shown, the 4 use cases implemented in this Catalyst project provide the foundations for the tools and methods that CSPs will need to enhance customer experience and pave the way for zero-touch customer-centric 5G networks.